All right, so before the break, we were getting a pretty good handle on vector component addition, okay, and all of that kind of stuff, and we've done quite a bit of work on that. We'll probably still do another day, maybe two on that. But what we're going to do today and tomorrow is just work on this little vector activity, okay, you and your group. Okay, groups can be, let's say, between 2 and 4 people, okay, no bigger than 4. And what you're going to be doing is just working on some kind of simple perpendicular vector stuff, looking at scalar versus vector points of view for trips and things like that. All right, so what you're going to get is a topographical map. How many people know what a topographical map is? Okay, yeah, since this is the era now of Google Earth and Google Maps and all of that, nobody uses these things that you used to have to fold up and take with you. Okay, so a topographical map looks like this. Okay, it's got a whole bunch of squiggly lines all over it, and the squiggly lines tell you about elevation. All right, if the lines are really close together, that area is very steep. If they are very far apart, it is not. If they are right on top of each other, it is a cliff. Okay, so if I was looking at, let's say, this area right here, okay, that would be, a hillside, but it wouldn't be insurmountable. Okay, if I was oops, I didn't want to do that. Okay, if I was looking at, let's say, it's hard to even see it in here, but these are really close right in here. That would be more like a cliff. You see how close together these ones get? That would be more cliff-like. This is probably a waterfall. Okay, so any of the blue little squiggly blue lines, those are creeks or rivers. Okay, and so yeah, like in here, you can see that they're quite close together. That would be much, much steeper, more like a cliff face. Okay, and anywhere that's green is below the tree line, and anywhere that's white is above the tree line. Okay, in case you don't know what the tree line is, it's what you can see on the mountains where the trees end. Okay, and it's just too cold above that for the trees to live. All right, so I can give you kind of an idea of the landscape in a two-dimensional representation. All right, so that's what a topographical map does. So what we're going to be doing in this activity is you're going to be planning your route from the start to 1, from 1 to 2, from 2 to 3, from 3 to 4, and from 4 to 5. And we're going to end at 5. Okay, we're not going back to the start. We're ending at 5. All right, and what you're going to do is for each day, you're going to plan a way to walk. Okay, and you're going to calculate your total distance, your total time, your average speed, your total displacement, and your average velocity. Okay, I know it sounds like a lot, but it's like V equals D over T. It's not terribly complex to do. Okay, so that's what you're going to be doing. Now, along the map, you'll see that there's like one red line. That's a road. Okay, and anywhere where you see little dotted lines, like this one here, those are trails. So if you can stick to those, it's a little easier going. Okay, you don't have to. You can bushwhack if you want. Okay, but understand that bushwhacking and walking on a trail come at a cost. That's what we're going to talk about now. Okay, so does everyone follow what the topographical map's going to be for? I'm going to come back to this and show you what I'll be looking for in just a minute. Okay, so I made that picture way too high a resolution. It's going to slow everything way down. Okay, so your assignment is to plan your routes, okay, to each of the destinations. When doing this, there are several things to consider and some rules that you have to follow, okay? And that is that conditions in the mountains can influence the speed at which you can travel, especially if you go off trail. If you're bushwhacking, it's going to take you longer because you can't go as fast, okay? So, for example, you need to look at how steep an area you want to cross is. If you're crossing the lines, then steepness matters. If you're walking parallel or along them, then it's not as important, unless it's a cliff, in which case you're not doing that. Okay? But if it's also a cliff, you don't want to cross the lines. That's the shortcut. But, there's the sudden stop at the bottom that is going to be problematic. Okay? All right, so you also have to look at whether you are crossing rivers. If you're on a trail, what will be at the river if you're on the trail? A bridge. And it's really easy to cross the river. If you're bushwhacking, it's an entirely different experience to cross a river. Okay, sometimes they can be raging torrents that are difficult to get across without falling and being swept away to your dad. So you have to be careful about how you cross, and it adds time. If you go across on a bridge, it doesn't add any time, you just go across the bridge. Okay, so little things like that. So here are the rules. Rule number 1, altitude affects speed. Okay, the higher up you go, the harder it is to go forward. If you've ever seen like videos of people climbing Mount Everest, when they get near the top, they take like one step and stop and rest for 30 seconds, and then take another step. And each one of those steps is like running 200 meters at sea level. Okay, like you're just bagged after each one. Okay, so if you are below the tree line and on a trail, so on a dotted line, you can walk at 1.5 meters per second. That's going to be an important number for you because you're going to use it to calculate your time that it takes you to walk. If you are above the tree line, you can only walk at 1.2 meters per second. Okay? Less oxygen, you go a little slower. The bushwhacker rule. If you go off trail and you are below the tree line, you can only walk at 0.75 meters per second because there's going to be stuff in your way. If you are above the tree line, you can walk at 1 meter per second. How come you can walk faster above the tree line?
Because you're not trying to walk through trees. It's
Right.
more of a straight line.
Exactly. There's no trees now. Once you're above the tree line, it doesn't really matter. It's more about altitude and you don't have a packed trail to walk on. All right, and the third rule is the silly salmon rule. You are not a fish, therefore any stream crossing not on a trail is going to add 15 minutes to your total time for that segment. So you will have to count how many times you cross streams not on a trail, okay, and add 15 minutes to your total time for the day for each time you do it. All right, because realistically, if you're crossing a river, okay, you would have to, make sure your pack is not going to get wet. Probably take your socks off so your socks don't get wet or whatever. Okay, you don't want to have wet feet for a whole day, stuff like that. All right. The second part of the activity is to practice using your kinematic skills. So for each day, you're going to have to measure the total distance traveled. Now, the way you do that on a map, because you're not going to be following a straight line, okay, is you're going to use like your headphone cable or a shoelace or something like that, okay, and you're just going to place it on the map. So. This is not a good example because it's kind of stiff, but wow. It's not good. Let's say I want to follow this trail here from start to 1. So this will give you a pretty good idea because you would definitely want to follow the trail from start to 1. That's the smartest route to take. Okay, so if I want to calculate the actual total distance, I'm going to put my headphone cable or shoelace on the map, and I'm going to do a better job than I'm doing. I'm going to make it take the shape of my trail. And then I'm going to mark the two ends like this, straighten it out, and measure it with a ruler. All right? And then I will use the scale on the map to figure out how far in reality this was. Okay? The scale is 50,000 to 1. Which means every centimeter on the map is 500 meters in reality. Okay, so if I get that this is, 10 centimeters long, okay, then 10 times 500. Okay, and I'll get that number of meters. Okay, everyone with me there? All right. Okay, so it's a pretty easy calculation, right? So that'll give you your distance. Okay, then, since that whole trip is on a trail below the tree line, I know that that entire time I'm going to walk at 1.5 meters per second. So I'd be able to calculate my total time, okay, using V equals D over T. Everybody follow me there? Okay. So that's the scalar part of the assignment. Okay. The vector part is going to involve doing this. Where would I draw a line that would represent my total displacement from start to 1? From start to 1, exactly. So that line there would represent my total displacement. Okay. Now I can measure that obviously and just use the scale, multiply it by 500, and I'll have my amount in meters. But I also need to know its direction. Fortunately, on the map there are grid lines. And those grid lines go north and south, and east and west. So I would just draw on here a north component and a west component. Okay? And you just have to make sure that they're parallel to the grid lines that you're working with. All right? And then you'd be able to calculate your direction, okay, using trigonometry. Everybody with me there? All right. So that gets you your total distance, your total time, and your total displacement for the day. Okay. You also need your average speed, which is just going to be your total distance divided by total time, and your average velocity, which will be your total displacement divided by your total time. Okay. That's what you have to show me for each day. Okay. So for each day, you're going to show me the distance, the displacement, the time, the velocity, and the speed. Okay. Now, that first day is pretty easy because you're walking all along the trail the whole way. Okay. I've made it really impossible to do that on all the other days. You're not going to be able to backtrack on a trail the entire time. Like for example, I cut the map off conveniently right here, okay, so that you couldn't take the trail all the way to number 2. You would have to bushwhack a little bit across the top of the map. Okay. So is that going to change your speed? It is, because now you're going to be off the trail below the tree line. So what I often recommend people do is, I say, pick some different colors and say like on the trail below the tree line will be red. So this whole day would be red, okay? But the next day, maybe I'm only going to go to here, and then I'm going to go across to there, and then I'll take the trail the rest of the way to 2. That would kind of make sense, right? Maybe I want to do it that way, okay? Or maybe you want to take a different route. But this route makes the most sense because I don't have to go across the peaks. Some people are just like, well, I'll just go straight across. Wow, that is not a good way to go. It might be shorter geographically, but it is certainly not going to be shorter chronologically or like effort-wise. It's going to be very difficult. Okay? So now I know I can walk at 1.5 meters per second for this distance, 1.5 meters per second for this distance, but for that one, only 0.75. And over this distance here, I made 2 stream crossings. So there's another 30 minutes on top of my total time for the day. Okay, kind of following what you're going to have to track. Right? It's meticulous work, but it's not difficult. Okay? You just have to kind of keep track and figure out what routes you want to take. Okay. Everybody kind of understanding what I'm looking for here? You can break this work up however you think is best for your group. Some people are like, you do day 1, you do day 2, you do day 3, or you do all the distances and you do all the displacements. I don't care how you break it up as long as everybody's got a job. Okay? You're not riding one person, making them do all the work, and you're riding their coattails, okay, to a good mark. Okay, that's not fair either, so make sure that everybody's got a job.
Are we handing it in individually?
No, this one you're handing in as a group.
Okay.
Okay, so what I would like you guys to do is just figure out who your groups are, make sure everyone's included, and then you're going to need the map, which is 3 pieces of the map. Okay, so you just take the first 3 on the top, and you're going to have to tape them together, and you're probably going to have to trim, because if I make the map go right to the edge, it cuts it off. Right, so you'll have to do a little bit of trimming and a little bit of taping, okay, to make them match up, and then you'll be good. Now, one thing to note is that cabin number 3 is right on the seam. It's circled, it's on there, but it's right on the seam. Okay, so sometimes people miss it, right? And down in the bottom corner here, there's a couple of other ones that are circled in here. Those don't have to do with what we're doing. That's from a backpacking trip I did before you were born. Yeah. Okay, so don't worry about those ones. Okay, so each group can take a map and an instruction sheet. Okay, and you can hand it in with this instruction sheet on the front, and you can write everybody's names on it. All right, we're going to have today and tomorrow to work on this. Okay, so you should be able to get it pretty much all done in class, right, and not have to figure out when you can meet with everybody. My recommendation is, though, that everybody takes a picture of the assembled map at the end of class, in case the person who's keeping track of the map ends up not being here tomorrow. right? And then you can go, oh, okay, well, we'll just grab another map and we'll quickly make our jot notes and whatever, and then at least everybody's got a copy of it. Okay? All right, let's get to it.
It's good. Wait. How are you supposed to find all you have is the distance? Well, you figure out the distance here. Oh, yeah, you just measure it. You just measure it. This one? Yeah, so you can still find the angle.
Any other groups needing the map?
That's why I'm saying where you move. Oh,
I have some scissors, yes, and some tape. Just when you're done with those, you can just put them on the desk with the maps. Okay, so guys, there's going to be one tape dispenser. Actually, there's another tape dispenser. Am I ever equipped? Okay. So it goes like.
They have letters.
All right.
You have the